Hello everyone, welcome back to the Roots of Unity. I'm Soumya and today we'll continue on the topic of series. We'll try to derive the formulas for the sum of r square and r cube in this video. So the sum of r square. The sum of r square means the sum of 1 square plus 2 square plus 3 square up until the limit n square. To find out a formula for this, we are going to use what is called the differences of cubes. Here we have a cube, the cube of k plus 1. Expanding this, we have k cube plus 3k square plus 3k plus 1. We bring the k cube to the left-hand side. Why? Well, you'll see that soon. Now, instead of k, we put in the values from 1 to n. We put in 1 first. We have 1 plus 1 whole cube minus 1 cube is equal to 3 multiplied by 1 square plus 3 multiplied by 1 plus 1. Now in the next lines we put in the values of 2 and 3 and we continue putting in the values up until n. Notice something interesting. If we add all of these lines of equations together, look at the left hand side. What happens when you add all of this? When you add them, the terms cancel each other out. Look at the 1 plus 1 whole cube term. The 1 plus 1 whole cube term gets cancelled out with the minus 2 cube. All of the following terms gets cancelled out with each other. The 2 plus 1 cube gets cancelled out with 3 cube, and the 3 plus 1 cube gets cancelled out with 4 cube, and it continues on. So adding all these lines, what we are left with is n plus 1 cube from the last line and minus 1 cube from the first line. Now to look at the right hand side. The first terms being 3 multiplied by 1 square, 3 multiplied by 2 square, 3 multiplied by 3 square, the squares, thrice the sum of the squares. So adding all of this, we have thrice the sum of r square with the limits of n and 1. Add in the second term, 3 multiplied by 1, 3 multiplied by 2. Those are thrice the sum of r with the same limits. And in the third term, we have the plus 1s. So we have n number of plus 1s which is equal to n. So we have a plus n. Taking this total line, this total sum, we write it on a new page to work on it. Our goal is to find the formula for the sum of r square. So we bring that part to the left hand side and everything else to the right. Break down the expressions, then simplify with each following line. We end up with n multiplied by n plus 1 divided by 2 multiplied with 2n plus 4 minus 3. Remember, on the left hand side we had thrice the sum of r square. So we divide the whole line by 3, thus getting the formula for the sum of squares, which is n multiplied by n plus 1 multiplied by 2n plus 1 divided by 6. This is the formula for the sum of squares. Now we go over to the sum of cubes. We work with the exact same method, this time working with the differences between the power of 4s instead of the differences between the cubes. So we have k plus 1 to the power of 4. Expanding, we have k to the power 4 plus 4k cube plus 6k square plus 4k plus 1. We do the exact same thing we did previously with the sum when trying to find the formula for the sum of squares. We bring k to the power 4 to the left hand side. Then we put in the values from 1 to n and add all of the lines together. To find the formula, we end up with n plus 1 to the power 4 minus 1 is equal to 4 times the sum of r cube plus 6 times the sum of r square plus 4 times the sum of r plus n. We put in the formulas for the sum of r square and the sum of r in this line. And then after calculating out, we end up with the formula, which is the sum of r cube is equal to n square plus n square multiplied by n plus 1 square divided by 4. This is the formula for the sum of cubes. We can use these formulas effectively combined with our knowledge of how to maneuver the sigma notation to solve numerous sums. So that's it for today's video. Thank you again for watching till now. In the next vid, we'll be studying the method of differences, the interesting part of this chapter. So be sure to check in next time. Till then, goodbye and have a great day.